Hello everyone, I welcome you all to the Infinity Vision platform. Right now I'll be doing one such question that came in your JEE examination. This question came on 26th August 2021 in shift 1. So let us see this question first. Question says, a source and a detector moves away from each other in the absence of wind with a speed of 20 meter per second. So you have been given this source and a detector. Okay. This source can move with the speed of Vs and this detector can move a speed of, let it be Vd. Okay, if the detector detects the frequency of 1800 Hertz of the sound coming from the source, then the original frequency of the source considering the speed of sound is 340 meter per second is. Okay, now this source will send the signal while it is moving away with the speed of 20 meter per second, which is already given to you in. So they are both moving with the speed of 20 meter per second, so away from it. Okay, now it sends the signal. This source will send the signal. Okay, let that signal frequency is f0. Okay, now the frequency which is heard by this detector is different because of Doppler shift, because this source and detector is relatively moving with respect to each other. Okay, now this source frequency would be capital F, and this is already given to you as 1800 Hertz, which is detected by this source. So we already know that this F must be equal to f0 velocity of sound, because sound has been the sound with this much f0 frequency has been sent to detectors. So if this source is moving away and this f0 and this sound is moving from towards this direction, so they are relatively they are moving away from each other, so that means this has to be equivalent to plus velocity of observer. Okay, here it has to be velocity. In this particular situation, this expression is given by plus minus v plus minus this plus divided by observer v plus minus velocity of source. Okay, source is this and observer or detect, or you can say write it as or detector also. Okay, so in this expression this will be putting the value, while if it is moving away from each other, so this source, because source is over here at the denominator, not at the numerator, so it would be equivalent to f0. Here it would be equivalent to plus velocity of source. What about detector? So detector is also moving in this direction, and the sound is also coming in this particular direction only, so the relative speed between them must be equal to v minus vd. Okay, now rest is clear, we have to just put the values. Okay, so we'll be putting the values because this detected signal frequency is 1800 Hertz, so it would be equal to f0 v, what is speed of sound, which is 340 plus, okay, minus 340 minus 20, because the speed with which they are moving away is 20. Again it would be equivalent to divided by 340 plus 20. So you'll be getting 1800 is equal to f0. This is 320 divided by 360. Okay, now you have to solve it and eventually you'll get the value of f0, which is 1800 into 36 by 32. This solving this, you'll be getting 2025 as your final answer. Okay, so the original frequency was 2025, which is sent by this source. Okay, now rest everything is clear. This is a question of Doppler shift, in which the Hertz frequency is different from the frequency which has been sent by source. Okay, depending on different other situation, if it is moving towards and if it is moving away, you can change this expression. Okay, sometime it would become v plus vd, sometime it would become v minus vd, depending on different situation. Okay, so this would be the Hertz frequency. I hope this question is clear to everyone. Thank you.